Hello everyone, welcome to another video session with Dr. Teng. In this video session, you are going to identify the structure of some matrices and then determine the types of these matrices. At the end of this lesson, you should be able to determine the following matrices: square matrix, column matrix, row matrix, diagonal matrix, upper triangular matrix, lower triangular matrix, identity matrix, and null matrix. The very first matrix that we are going to determine is square matrix. What is the order of the matrix in A? Yes, this is a 2 by 2 matrix because it has 2 rows and 2 columns. Let's try another one. What is the order of the matrix in B? Well done. This is a 2 by 3 matrix because it has 2 rows and 3 columns. Now, by looking at the matrices in A and B, which one looks like a square and which one looks like a rectangle? You are right. The 2 by 3 matrix in B looks like a rectangle, while the 2 by 2 matrix in A looks like a square. How about the matrix in C? What is the order of the matrix? Good. This is a 3 by 2 matrix because it has 3 rows and 2 columns. Lastly, what is the order of the matrix in D? Well done. This is a 3 by 3 matrix because it has 3 rows and 3 columns. Now, by looking at the shape of the matrices in C and D, which one looks like a square and which one looks like a rectangle? Yes, the 3 by 2 matrix in C looks like a rectangle, while the 3 by 3 matrix in D looks like a square. From these 4 matrices, do you observe that matrix which looks like a square must have equal numbers of rows and columns? Can you give a brief definition for a square matrix? Good. A matrix having the same number of rows and columns is called a square matrix. The second type of matrix that we are going to determine is column matrix. Here are some examples of column matrices. What is the order of the column matrix in A? Yes, the order is 2 by 1 because it has 2 rows and 1 column. Let's try another one. What is the order of the column matrix in B? Yes, the order is 3 by 1 because it has 3 rows and 1 column. Lastly, what is the order of the matrix in C? Good. The order is 4 by 1 because it has 4 rows and 1 column. What is the common characteristic of these 3 column matrices? Did you notice that each column matrix has number of columns equals to 1? Can you give a brief definition for a column matrix? Well done. A matrix that has exactly 1 column is called a column matrix. The third type of matrix that we are going to determine is row matrix. Here are some examples of row matrices. What is the order of the row matrix in A? Yes, the order is 1 by 2 because it has 1 row and 2 columns. Let's try another one. What is the order of the row matrix in B? Yes, the order is 1 by 3 because it has 1 row and 3 columns. Lastly, What is the order of the row matrix in C? Good. The order is 1 by 4 because it has 1 row and 4 columns. What is the common characteristic of these 3 row matrices? Did you notice that each row matrix has number of rows equals to 1? Can you give a brief definition for a row matrix? Well done! A matrix that has exactly 1 row is called a row matrix. Let's move on to another type of matrix called diagonal matrix. Why this type of matrix is called a diagonal matrix? Here you see a square. These arrows indicate the 4 equal sides of a square. As you see, if I draw a line joining 2 opposite vertices, this particular line is called the diagonal of a square. Let's consider a 2 by 2 square matrix. By using the picture of the square, you can see that the elements that lie on the diagonal are A11 and A22. Elements which do not lie on the diagonal are A12 and A21. If all the elements which do not lie on the diagonal are zeros and all the elements at the diagonal are non-zeros, then you will have a 2 by 2 diagonal matrix. Let's try another one. Consider a 3 by 3 square matrix. By using the picture of the square, what are the elements that lie on the diagonal? Yes, the elements A11, A22 and A33. Which elements do not lie on the diagonal? Yes, the elements A12, A13, A21, A23, A31 and A32. If all the elements which do not lie on the diagonal are zeros, and all the elements at the diagonal are non-zeros, then you will have a 3 by 3 diagonal matrix. From the previous examples, we can say that a diagonal matrix is a square matrix with all the elements at the diagonal are non-zeros and with elements that are not at the diagonal equal to zeros. Let us continue to another type of matrix called triangular matrix. How does a triangular matrix look like? Firstly, we start with a square. As you can see, the square can be divided into 2 equal halves at the diagonal. These 2 equal halves are in fact 2 triangles. The green triangles forms the upper triangular of the square, while the blue triangle forms the lower triangular of the square. Therefore, we can expect to have 2 types of triangular matrix. One is known as upper triangular matrix, the other one is known as lower triangular matrix. Let us start with upper triangular matrix. Here is an example of upper triangular matrix. The order of the matrix is 2 by 2, which indicates that this matrix is a square matrix. As you can see from this example, all elements which lie in the green triangle are non-zeros. Elements which do not lie in the green triangle are zeros. Here is another example of upper triangular matrix. The order of the matrix is 3 by 3, which indicates that this matrix is a square matrix. Do you see that the elements which lie in the green triangle are non-zeros? Lastly, this example shows a 4x4 upper triangular matrix. Do you see that elements at the diagonal and above the diagonal are non-zeros? After studying these three examples of upper triangular matrices, what can you say about upper triangular matrix in general? Good. An upper triangular matrix is a square matrix with all the elements at and above the diagonal are non-zeros, and with elements that are below the diagonal equal to zeros. Now we move on to lower triangular matrix. The characteristic of lower triangular matrix is opposed to the characteristic of upper triangular matrix. This is an example of lower triangular matrix. The order of the matrix is 2 by 2, which indicates that this matrix is a square matrix. As you can see from this example, all elements which lie in the blue triangle are non-zeros. Elements which do not lie in the blue triangle are zeros. Here is another example of lower triangular matrix. The order of the matrix is 3 by 3, which indicates that this matrix is a square matrix. Do you see that the elements which lie in the blue triangle are non-zeros? Lastly, this example shows a 4 by 4 triangular matrix. Do you see that elements at the diagonal and below the diagonal are non-zeros? After studying these three examples of lower triangular matrices, what can you say about lower triangular matrix? Well done! A lower triangular matrix is a square matrix with all the elements at and below the diagonal are non-zeros, and with elements that are above the diagonal equal to zeros. Let us continue to another type of special matrix called identity matrix. The symbol of an identity matrix is denoted by the capital letter I. Let's observe the 2 by 2 identity matrix. You should notice that every element at the diagonal are set to 1, while the rest of the elements are set to zeros. As for the 3 by 3 identity matrix, do you see that this matrix is a square matrix? What can you say about the elements at the diagonal and the elements not at the diagonal? Yes, every element at the diagonal is set to 1, while the other elements are set to zeros. Let's try to analyze the 4 by 4 identity matrix. Do you see that every element at the diagonal is set to 1? From these three examples, what can you say about identity matrix in general? Yes, an identity matrix is a square matrix where the elements at the diagonal are 1 and the other elements are all zeros. Finally, we arrive to the final matrix for today's discussion. This matrix is called Null Matrix. A null matrix is a matrix where all the elements are zeros and denoted by the capital letter O. Here is an example of a null matrix. You can see that all the elements in the null matrix are zeros. That's all for today's video session. Thank you for your attention and see you again in our next meeting.